Technology sharing across Autodesk products means you get the benefit of some feature developments from the wider Autodesk portfolio. The latest example of this in Autodesk Powermill 2020 is the option to calculate a triangulated fillet model, which can be used during toolpath calculation to allow smooth arcs to be added into the internal corners of a toolpath to help protect your tools and preserve feed rates. Unlike arc fitting, which is applied to the toolpath after scanning and is restricted to 2D toolpath segments, such as the step downs on a constant Z toolpath, the fillet corners option works on the model before scanning, and so can be used for 3D toolpath segments, allowing options such as spiral on steep walls to gain corner arcs. In this example, we have a couple of toolpaths on this die, both calculated and uncalculated, where this can be seen. Let's look at the uncalculated steep and shallow toolpaths first. Activating and accessing the settings of the first toolpath, note that the spiral option is unchecked for the steep areas. Let's hit calculate and generate the toolpath. If we close the form and zoom into the internal corners, we can see that because the 6mm diameter ball nose tool is equal to that of the corner fillets of this model, we end up with sharp direction changes in the toolpath. This creates a couple of problems. The first is that the cutting tool may be subject to a shock load as a result of excessive material engagement. This can lead to increased tool wear, and it may even break the tool or possibly damage the workpiece. To combat this, operators may be inclined to reduce the feed rate, meaning the programmed feed rates are not achieved, which increases the overall cycle time. Powermill allows us to see how the triangles have been generated through the model drawing options. From the View tab, select the Additional Options pop-out dialog from the Appearance section to access the model drawing options. To access a secondary page, press Ctrl and Tab on your keyboard. This allows us to toggle the triangle display on. Select the Draw Triangles checkbox to show the triangles used. Note that the triangles match the fillets of the model for this toolpath. Let's undraw the triangles and close the form. Activate the second steep and shallow toolpath and access the settings. Note that the spiral option has been checked for the steep regions. In Powermill 2019, the high-speed options were unavailable for steep and shallow toolpaths, as arc fitting could not be applied to the shallow toolpaths. But in Powermill 2020, the high-speed section is active because it is from here that we can access the option to fillet corners. In this toolpath, we will set a fillet radius equivalent to 1 times the tool diameter. In other words, Powermill will add a 6mm internal corner fillet to the model triangulation for use in the toolpath calculation. Let's calculate the toolpath. If we close the form and zoom into the corners, we can now see smooth arcs where previously there was a sharp move. If we draw the previous toolpath to compare the difference, it's clear to see. Likewise, we can also see that the shallow regions have also respected the fillet, preventing the tool from engaging into excessive material. Going back to the model drawing options, if we draw the triangles, the calculated fillet can now be seen in each internal corner. And assuming no model changes or radius adjustment, this fillet result will be cached, allowing it to be used again, saving calculation time later. Let's undraw the triangles and close the form again. As well as working with steep and shallow, this option also works with optimized constant Z toolpaths, as can be seen on the pre-calculated toolpath here. By using the new fillet corners option in Powermill 2020, greater protection is offered to your cutting tools and parts when entering internal corners, by avoiding the shock loading associated with excessive material engagement, allowing parts to be run at their optimized programmed feed rates, and ultimately resulting in faster cycle times.